we'll have this project for takeoff excavation calculation, and as you see, this is the plan for foundation or footing, and we'll use the Excel sheet to do that. And I previously explained how we did get the numbers for each part. So we'll start with the Excel sheet, will be our guide here. So first of all, you have to start at this point where it says that you need to define the type of soil. And this soil, as you can see here, it says it is earth. So that one, first of all, put in our Excel sheet, this is earth. The bad thing about this Excel sheet, it will do all the calculation for you. Now the earth being the soil type here, it means that for each 2 vertical, it goes only 1. So meaning that the ratio is 1 to x is 1 to 2. So now we'll go to the grade. The grade, as you can see here, is given us 210.3, that's one, and the other is given on this side as 210.2. So we'll record both of these, and it will do the average for us. So 210.3 for the first one, and the second one is 210.2, and it will do the calculation for us, as you can see here. Now, the height of excavation. So the height of excavation, this is the average 210, and this says less given elevation. So we need to go and look for the less given elevation. If we scroll down a bit here with the sketch, you should be able to see this value. It says 208.05. So we'll record this one, and don't forget to put negative. So it is negative 208.05. Now I'll give you the difference, the height. Now we don't have any details for that to subtract, so the height will be 2.2, as it is here. Okay. Now see, like I said, the soil being 1 to 2, this is already recorded here by the Excel sheet automatically, but if this is not, which is the case when you have to do this on a piece of paper, you have to put 2 here, and the height is 2.2, and it will do the calculation for you, and the calculation yields 1.1. So the distance horizontal is 1.1. Okay, now come to the footing projection. So again, we're trying to calculate the bottom of the footing and the top of the footing, because the top of the footing will be something, this will be something like that. So I'd like to know what is the distance from here to here. This was explained in the previous video. So the footing here is, as you can see, it reads 450 by 200 here, as you can see. So we'll record this one here. So it is the 450 is 0.45, and the 200 is 0.2. That is the wall thickness. So the wall thickness here, because the other one is for wall thickness, which is given here, 200 millimeters. So the wall thickness should be minus, less, this is 0.2. So we'll get this value, which is, this is the flare part, like the extra. Now the pay line is always 60 centimeters from the face of this footing. So it is always, as we did before, the distance from here to here is 60. This will be 60 before you start to do that. So it's already given here, but you have to do this yourself when you do a paperwork. So the top will come to this top factor at 1.8. Now when you average, so this is the top part, and you average 1.8 times 0.7, you'll get the value, average value in the middle here will be 1.28. Okay, so now we'd like to get the length of perimeter excavation. That is for the surrounding the basement and the entire building. So we need to put the value for the front and rear, and as you can see from the sketch here, this measurement is 14 and this is 11, but if you ignore this part only, which we will ignore for excavation, then this part, if you continue with this part here, they'll have 14 by 17. This is 17 and this is 14. So we'll input these numbers in here. Uh, 14, 14, 14, and then 17, 17, 14, and then we have 17, 17. So that would give us the total perimeter exterior face of the building 62. And of course now the point here is we'd like to calculate the perimeter, the center line for the perimeter excavation, which is this one. So it will be, we'll do the 62 plus 8 multiplied by half of the average, which is 1.28. So that's the calculation when you do the manual calculation. And the value for center line for the perimeter excavation is 67. Okay. Now the bulk excavation is the excavation that has only these parts, and that will be the perimeter, which is, we'll break it down into two pieces. So we can have this plus the garage, the remaining of the garage, plus this. So this part will be 11, 14, and 11. And of course the depth is the same. Now for the second one, for the garage part here, we'll do this part. So this is 6 and this is 7. 6 and 7. So the 6 and 7. 6 meters, and this is 7 meters. So we'll get the bulk excavation, which was the inside the building. Now the perimeter excavation, and this is the bulk excavation. Now for the perimeter excavation, we have the center line, and we have the average width, and we have the depth. This is how we calculate it. But for the bulk, we do have the length, width, and depth. So just keep in mind that is how it is done. Anyway, so now we get the total of excavation is equal to 619. But there's a swell also. It will be larger than what it is. And for earth, is 15% according to the first document that we had. So you have to add the 15%, which is 92. So the total of the excavation, including the bulk and perimeter, is equal to 712. It will be rounded up to 713 cubic meters. Now the backfill. Where do we backfill? We backfill all around the building, but not inside this part. We will not backfill inside this part because this will be the basement. All around the building, and there will be also backfill inside for the garage part. So let's see how we will do that. So for the backfill native, that will be the perimeter all around the building. We have the perimeter excavation is given here as we did the calculation 188, right? So all you need to do is put the 188 here, but you would add also the compaction factor of the soil, of the earth, which is again is 15% for the type of soil, which is earth, and that will yield 28. So add 28 to 188, you will get the total of backfill is equal to 216. Now I'm not going to go through this, but we'll just let go that part. So the bulk excavation. So we're good with the so I'll come to garage backfill here, because if you look at, there's a detail for the garage backfill. If we make this a bit larger to see, so we're doing the backfill on this side. That's where the garage is, and this is where the concrete slab for garage is, and the granular material. So we have the height already 2.3 here. This one 2.31, so it'll be 2.32. So I'll put the total height here. Is equal to 2.32. 2.32. And then less exposed area. The exposed area is this part. 225, you see this number. So 223, 225. So this will be rounded up to, this will be 0.225, so it'll be 0.23. 0.23. Of course, this has to be less. Just make sure that you don't forget the negative sign, because it says less. Wherever it says less, I have a problem here. So this will be negative 0.23. And then less garage slab. The garage slab is given as, and the detail here is 100. So 0.1 minus 0.1 minus 0.1. And then less the granular part is, the granular part it says 250 here. So come here again, and negative 0.25 plus basement slab. Now the basement slab is this part, because you have to add this part, right? This, and this is equal to 75 millimeter, which is 0.08. So you have to add here 0.08, and then plus of course the footing. This footing is 200. Again 0.2. So we get the height for backfill, and the garage area is 2.02. Now we'll calculate the garage area itself. So we have, of course, again, let's just make this a bit larger. So you have 7, and this is 9.2. 7, this is 7, and this is 9.2. So garage area here is 7, and this is 9.2. But we need to subtract from, because this is inside, right? This is going to get the backfill will be inside. So the inside we have to subtract from 7 this thickness of the wall, and same thing goes for the 9.2. You have to subtract this thickness and this thickness, so you have two thicknesses to be subtracted, and the thicknesses of the foundation wall is 0.2 or 200, as you can see here. So put them here. So it is minus 0.2 minus 0.2, and same thing goes for these. It is minus 0.2 and minus 0.2. So it will do the calculation for us, and the height is already here. This is what we calculated here. So we made a mistake here. See, it gives negative, so this should be 9.2, and this should be minus 0.2. So now these numbers make sense, but it was negative at the beginning. And again, the compaction part will be so we're doing the garage, and it's 12%. So it comes to 131.4, so it'll be round up to 132. Now we'll do the weeper tile. We said, as we did the weeper tile previously, is here. This is the weeper tile. So the calculation for that part, we need the perimeter of the building, which is, we said previously, is technically 14 by 17. So it will be so we don't need to bother much about this. So it will be it's 14 and 14. You have 11, so it will be around only the building, not the garage part. So this will be 11, and this will be 11, so the total comes to 50. Now the calculation for the center line for the weeper tile has an equation, as you know, and it is already done for us here. So it comes to, we have 0.13, and the weeper tile it is 100. The weeper tile is 100 millimeter. So half of it will be, so say the weeper is 100 millimeter here. So half of it will be 0.05. So we have to put this here. 0.05. So we get the numbers like so. Now I'll move on to sub-drainage. So weeper tile here is 100 millimeter, and diameter per tile is 10, 0.1, and the coverage is given here, so that will end the calculation for us.